Exoplanets are planets that orbit stars outside our solar system. They come in a wide variety of types and characteristics, and studying them has become a major field of research in astronomy. Here's a more specific and detailed overview of exoplanets. Discovery of exoplanets. Exoplanets were first hypothesized in the 1590s by Johannes Kepler, but it wasn't until the 1990s that we began to detect them. The first confirmed discovery of an exoplanet orbiting a Sun-like star, 51 Pegasi b, was in 1995 by Michel Mayor and Didier Queloz. Since then, thousands of exoplanets have been discovered. Methods of detection. Several methods are employed to detect exoplanets, each with its strengths and weaknesses. Transit method. When a planet passes in front of its star from our viewpoint, it causes a temporary dimming of the star's light. This method is used by telescopes like Kepler and TESS, Transiting Exoplanet Surveys satellite. Radial velocity, Doppler shift. This method detects the slight wobble of a star caused by the gravitational pull of an orbiting planet. This was the first successful method of detecting exoplanets and is still widely used. Direct imaging. This method involves taking pictures of planets by blocking out the star's light, allowing for the observation of the planet itself. It's a challenging method due to the brightness of stars. Gravitational microlensing. This occurs when a planet's gravitational field bends and magnifies the light from a distant star. It's a rare event but can be useful for detecting planets at greater distances. Astrometry. The precise measurement of a star's position in the sky. This method tracks the star's motion to detect the presence of a planet. Types of exoplanets. Exoplanets come in various categories based on their size, composition, and position relative to their stars. Some of the key classifications include gas giants. Like Jupiter and Saturn in our solar system, gas giants are large planets mostly made up of hydrogen and helium. They tend to form farther from their host stars. Super-Earths. These planets are more massive than Earth but lighter than Uranus and Neptune. They can be rocky or gaseous and may have conditions conducive to life. Neptune-like. These are similar to Neptune in our solar system, having thick atmospheres with hydrogen and helium but with lower densities than gas giants. Terrestrial planets. These are rocky planets like Earth, Venus, and Mars. They have solid surfaces and are generally smaller than gas giants. Hot Jupiters. These are gas giants that orbit extremely close to their stars, resulting in high surface temperatures. Ice giants. Planets like Uranus and Neptune, which have more ice and heavier compounds like water, ammonia, and methane in their atmospheres. Habitability. One of the most exciting areas of exoplanet research is the search for habitable planets or Earth-like planets. The key factors that make a planet potentially habitable include the habitable zone, often referred to as the Goldilocks zone. This is the region around a star where conditions may allow liquid water to exist on the surface of a planet. Atmospheric composition. A planet's atmosphere needs to have the right composition, e.g., oxygen, nitrogen, carbon dioxide, to support life as we know it. Planetary size and composition. Planets that are too large may have crushing atmospheric pressure, while planets that are too small might not have enough gravity to hold onto an atmosphere. Stability. The planet's orbit should be stable over long periods to allow for the development of life. Some exoplanets in the habitable zone of their stars are sometimes referred to as Earth analogs, because they resemble Earth in size, temperature, and potential for liquid water. Exoplanet atmospheres. One of the most active areas of exoplanet research is studying the atmospheres of exoplanets to understand their composition, potential for life, and even detect biosignatures. The methods used for this include transmission spectroscopy. During a transit, some of the starlight passes through the planet's atmosphere, which can absorb specific wavelengths of light. This allows scientists to identify the chemical composition of the atmosphere. Emission spectroscopy. When a planet emits its own thermal radiation, heat, this can be analyzed to understand its atmosphere and surface temperature. Polarimetry. A technique that measures how light is polarized after passing through a planet's atmosphere. Notable exoplanets. Some exoplanets have garnered attention for their intriguing properties or potential for habitability. Kepler-22b. One of the first exoplanets found in the habitable zone, it is 600 light-years away from Earth and has a size similar to that of Earth. Proxima Centauri b. Orbiting the closest star to the Sun, Proxima Centauri, it is within the habitable zone, though its habitability is uncertain due to solar flares from its star. TRAPPIST-1 system. A system of 7 Earth-sized exoplanets, 3 of which are in the habitable zone of their star. HD 209458b. Osiris. The first exoplanet where an atmosphere was detected, it is also notable for losing its atmosphere due to the extreme heat of its close orbit. Future missions and exploration. There are several upcoming or planned missions that will revolutionize our understanding of exoplanets. James Webb Space Telescope, JWST. Launching in December 2021, JWST will provide unprecedented capabilities for studying exoplanet atmospheres and detecting signs of habitability. Plato, planetary transits and oscillations of stars. A mission by the European Space Agency set to launch in the mid-2020s to detect Earth-sized planets in the habitable zone of stars. The Nancy Grace Roman Space Telescope. Set to launch in the mid-2020s, this will have a primary focus on exoplanet detection through microlensing and studying their atmospheres. Challenges in exoplanet research. Distance. Exoplanets are often extremely far from Earth, making detailed study difficult. Interference from stars. The brightness of the stars that exoplanets orbit makes it difficult to directly observe the planets. Uncertainty in habitable conditions. While scientists focus on finding Earth-like conditions, the potential for life could be much broader than we currently understand. In summary, exoplanets are a rich and complex area of research, with discoveries happening at a rapid pace. With each new finding, we learn more about the vast diversity of planets out there, the conditions required for life, and the nature of our universe.